everyone. My name is Edgar. I'm a PhD student here at the Computer Vision Center. So today I'm going to talk about differentiable computer vision, which is a work that we have been done here in collaboration with the Open Source Vision Foundation, which is the organization holding OpenCV, and also now in collaboration with the Robotics Institute. So this talk is about an introduction to Kornia. How I'm gonna tell you what's Kornia now. So basically, Kornia it's a computer vision library for deep learning, and it comes from the fact that during the starting point of these new deep learning era libraries, we found that there was no. Well, we had this question actually. So all the algorithms were implementing end-to-end stuff using deep networks, but then we came out with this question that where was the classical computer vision in these frameworks? So the answer for that was that there was this kind of a black hole area. So none of these libraries were implementing classical vision methods. So, and this is for the reason of Kornia. So Kornia, we call it as an open source differentiable computer vision library for PyTorch. So which means that we implemented basically many of the classical computer vision algorithms in PyTorch, all of them from scratch, but at the same time relying mostly on the API, the curated API from OpenCV. So just a few items to summarize what are the different features from Kornia. So Kornia, as I said, it's in PyTorch, so it means that inherits the different properties from PyTorch that if you have been working with PyTorch, you might know, like that it's differentiable. It has a transparent API and parallel programming, so you can run on different devices, CPUs, GPUs. Then you have this distribute API that you can send over to different devices. And then finally for production, using the Torch JIT compiler. Well, this is a small snippet that if you have time, just check it, that how easy you can implement all these features that I was mentioning using combining PyTorch and Kornia now. And then coming to the functionalities that we have, so as every vision library, we have divided by, let's say, a big vision topics, the different models we have. So let me explain it very briefly, all of them. So we have a data augmentation model to perform augmentation on the GPUs in batch. Then different algorithms that you could do image enhancement, like transformations on intensities, normalizations. Then different color spares conversions. Then we have a whole module dedicated to the feature detection. You might know, like the Harris and Hessian detectors, or basically for people that's working on local features. Then we have another model for image filtering, implementing very basic algorithms for doing image smoothing, for example. Then another module dedicated for edge detection, which implements basically some of the algorithms for, high-level algorithms for edge detection, like Sobol, Laplacian. And then another module, probably which is the core for the library, which is the geometric module, which have a very also high-level routines for doing geometric transformations on image tensors. So you have some examples here for classical rotation translations, basically affine transformations. Even you could apply homographies in this module, and now we are introducing also for 3D transformations. Then related to this module, we have also a low-level API that you could use it also to transform the tensors using a more complex structures. And finally, for geometry, we have another set of functionalities for doing also 3D geometry, like epipolar geometry, or an API. We'll have an API for to work with perspective cameras. And then finally, a module for that has a different vision, specific vision loss functions that could be used for several tasks like image reconstruction, semantic segmentation, or if in case you are working with heat maps. So that's it. Then just very quickly, some of the examples that we have in the paper. For example, where we show how you can use backpropagation with all these algorithms. We have different examples like for image registration. Another one very similar for multi-view depth estimation. Then another example showing how you could do an adversarial tag using all the local features modules that we have. So, and then a bit of information about Kornia. So Kornia it's an open source library. So it's in GitHub. We have an Apache 2 licenses, and now the community. It's starting to grow. So everyone is very welcome to contribute. It's very easy to contribute. We have a lot of information there to do, or otherwise you can contact me or any of or the other contributors. And in case you want to know more information, we have submit a paper at the WOC 2020. So this last a few months ago. So yeah, check it out. And now we are actually submitting an extended journal version of it. So I hope it will be out soon. And yeah, and part of the ecosystem. So Kornia is part of it's supported by many organizations like PyTorch itself, AWS. It's hosting all the testing, and many other organizations are already using it. Yeah, so feel free to contact us. Just visit the website or just go to Twitter. We are very active there, and of course check the GitHub repository. And yeah, that's it.